Hello, folks. This is part three of me solving LeetCode problem 1920. The problem is build array from permutation. I was actually thinking about this problem last night and today morning, and I realized one thing, right? Let's actually go through the problem. So basically, you have um, a zero indexed array, and the array has numbers. Starting from 0 to array size minus 1, and it's just ordered in some form, right? Like it can be just, for example, if the size is 5, it can just be 0, 1, 2, 3, 4, or it can be anything, right? And you need to create another array. So let's do paperwork 5 here. And so I'm actually writing down what are the paperwork I'm doing. So if you think about this, you're basically trying to actually get, so this is the nums, right? This is the nums. And the index is basically 0, 1, 2, 3, 4, 5. If you think about it, what we're asking is basically we want an ans which basically tells you, let's say if it's 0, you want what is the value. So you have to consider these as indexes, right? These are the indexes of ants, right? And like for example, if you say ants of one is basically nums of one. Nums of one is two, right? And then you have nums of two. So basically, these are, these are going to be like, what do you say? You basically want what is the value of nums based on this as the index. If 0 is the index over here, then 0. If 2 is the index over here, then you get 1 here, right? If 1 is the index, you get 2 here, right? So if it's like this, 1, 2, 2, 1, then it's just swapped. And let's say here for 3, we say 5. So then at index 5, you have 4, so 4 comes here for ants, right? So let's say you find out the answers. You realize that it's just, I know this is pretty straightforward, but still, here you get 1 and then 2. And for ans of 3 is basically nums of 3. Nums of 3 is 5, right? So what is the thing at 5, right? You basically go like this. So you need ans of 3, and you basically go down, like find the value, and use that value as an index and do this. So it's like kind of like a this let me just put it. So you're going down and then you're going up like this to a different index. Let's say this is the index I. You go to the value x and you find out what is x, right? This you can basically also do something like do this like this. So you have x, and then you find out what is at x, right? Find out that, let's say, for example, it's y, right? So you do this, and then you realize that over here, let's say you have an arrow, so a downward arrow, not sure it's possible. Basically, you need a downward arrow. Anyways, so here you do have an upward arrow, so let's say there's x, right? So this is I, and this is this, and now x here. You go to x, and then you come down and you get y. So now, so you basically go down and then go. right to this or left wherever it is. The x can be on the right or left of x, left of I. So I can be less than x, or I can be greater than x, or I is equal to x. So you can go in any direction, but you realize that you have to do this thing, right? And the other thing is if I and x are equal, you actually just get the same value because if I and x are equal, then nums of I is basically nums of let's say it's nums of I is x, right? And nums of x, you say nums of x is also the same as nums of I because x and I are equal, and nums of I is again x. So and x and I are the same, so you can say it's I or it's x. So it's the same value. So whenever we find the two values are same, we can actually just put it there. And you also realize that the new value, that the overwritten value is like if we have to start overwriting, the overwritten value is the same as the old value, which is 0. Because both are same and you just put the same value. So if two values are equal, then you just don't have to do this traversal, right? Um, the next thing is I was wondering how to not use more space, right? Basically, that's how you don't create this ANS instead, right? So the value for this is 354. For this is 4, so this is 3 5, and then for 5 it's 4, so it's 3, right? So you have the value over here. I think this is the answer. Let's check. Yeah, that's the answer. So so now if you think about it, how do you do this in nums itself, right? Nums, the value is this. Now, let's say you overwrite nums. How can you do this without using an extra array, right? You start from 0, so both are equal, so you just do this. You don't have to store anything. For 1, and you can actually notice that in 1, it's 2, and 2, it's 1. So it's like you can actually swap this if this is the case. If I has x and x has I, right? So basically, if nums of I is equal to x and nums of x is equal to I, then you can actually realize that nums of I is basically nums of I is x, so nums of x because let's see this as so this is equal to this as nums of I is equal to x. And then you can actually say that nums of x is equal to I as nums of x is equal to I. So now you realize that your ANS of I is basically just ANS of I is just I, right? So so let's say it's in this case it's one, but basically if value over here is like this, you can just do this. You have noticed this in our paperwork also that if you know for now let me just check this out. Nums of I is x, nums of x is I. You want ANS of I which is this. So nums of I is basically I if this, right? If this. And you also realize that for the same thing, um, for x, right? So one moment. So if it's x, right? The values are just different. Like if it's just one, two, and two, one, like this whole thing. These two are equal and these two are equal. So I x and x I. So in this case, you say nums of x is equal to nums of I because as nums of x is I. X is I, right? And then you realize that nums of I is basically x, this is x, as nums of I is x. So you realize that ans of x is equal to x if this is true, okay? But this does not just make x as any value, x is a specific value over here. So you can't just say, if this is true for everything, we can do this, right? Like ans of 3 is just 3, but no, it's not the case. Ans of 3 is basically, um, you see, ans of 3 will basically be, x, which is basically the value at the thing 3, because so at 3, 0, 1, 2, so it's 1, right? So you need to understand what we are referring to as x. X is not a generic any value, but instead, I mean, it is a value, but this is not for all the values or all the indexes or all the values. Just for a specific case where you have, I is equal to y, right? Basically. And this is x, yes. Basically, that is I is equal to y, right? If I and y are same, then this is what happens, right? So, nums of x is equal to y basically, and yes. So, but then you can also realize that this can happen in a different way. Like, before we go there, I mean, for example, you can go to 2, 2 can point to 3. For example, here 3 points to 5, 5 points to 4, so and then 4 points to 3. At some point, you will end up with the same value, maybe, or maybe not, let's see. But if you do end up like that, then you can actually understand that this is kind of like this, right? 1, 2, 2, 1, you're ending up, but it can take multiple turns also. Now, why I'm talking about this is how can you actually, first of all, store these values just like that? For example, 1, now I say the value of 1, 2, 2, it's 1, right? Now I need to store the old value of 1. I need to store it as 2, and I need to say that it was at index 1. So do I have a map which says 1 points to 2, which is the old value, map of old values, right? Uh, do we do that, right? So let's just copy this out and let's write it down here, right? So do we have a map of old values? So once you do this, next you go to 2 and you say 1. What is, you have to check the old values first before you actually check the actual value. If you check the actual value, it will be 1, but that's wrong. You don't want the actual value because this is the new value. First, check if there is an old value. And if there's an old value, you have 2 over here. So 2 points to 1, 1 points to 2. So it's this, right? Once you realize that this old value is used, you don't need it again because every value is just used once, right? No one else will have, no other index will have 1 as the value. Only one of them will have 1 as the value, and once you use the old value, you can delete it. So you can use the space. And then the next thing you can do is next 3, 5, right? So for 3, 5, you see that 5 points to 4. So it's 3 becomes, so this becomes 4, and the old value of 3 is 5, right? So now you keep this, and next you go for 4. You see that this is, 4 points to 3. So you notice that 3's old value is 5. So you write that down and you delete it out, right? Um, and then finally, uh, you also remember that you overrode this. So you need to write down that 4's old value, the index 4's old value was 3. Right, and then finally you see 5, 4, first check the old value, it's 3. So we are always having one, in this case, one old value. If I take a paperwork, older paperwork, they've had big inputs also. This is one way of doing things, keeping a map, right? So, for example, this is one big number, big thing, right? For this, let's see if we can actually have, we can do the same thing. We can do the same. So, we add this, and let's try to see if we can actually do the same thing, right? So, if the both the values are same, we just don't have to do anything. We just move on. And if the values are different now, one, we are looking at one, we just traverse one by one, right? If you're looking at one, you say 11, 11, 1. So it has 1, but the old value, map of old values, you say 1 was pointing to 11, right? Um, so maybe I can start writing down I equal to 0 here, 0, and keep this on, right? Next, I equal to 1. I say nums of 0 comma 1, right? Old value is this. And next, I equal to 2, right? For 2, you have 9, 9 has 3. So you just say you have map of old values, um, and we have it as 1 points to 11, and here 2 points to 9. First, we write that down, and then you make the change of this. You should ideally have this first, and then you make this first. You say numbers, and this one 2 points to 9, 9 points to 3, so you just say 3. Fine. So 3, right? So we can check if this is right. We'll check it out. Next, we have I equal to 3, right? 0, 1, 2, 3. And so you have the map of old values. You will do you need to change it? Like so 3 it points to 4, 4 points to 7, right? So you say the old value of 3 is 4, and then you say 7. For this old value of 3 is 4, right? Old value of 3 is 4, and then you say 3 points to 7, so now you'll say 7, right? So this is 7. So your old values is basically increasing, right? Can you see that? So then next is I is equal to 4. You create a map of old values again. You have it, and you update it. And so now, as in, you need to add something probably because for I equal to 4, it's 7 and 7 points to 8. So before changing the value to 8, you note down 7. 4 points to 7, and you store 8, right? So 8, right? It's 7. 7 is an existing, so it's 8. And then I equal to 5. Now you have the map of old values, right? Now what you do is I is equal to 5, right? So 5 is this 10. 10 maps to 2. So 5 points to 10, we have to note it down. And then we make 2, right? So we say 5 maps to 2, the old value. And we get 2 over here, right? Then I equal to 6. You have a map of old values, just keep it keeps increasing. So once you do this, So I is equal to 6. It's 5. First check if there's an old value of 5, right? Usually, if you have a number less than this, you can check the old value. I mean, in this algorithm, we go one by one. I increases one by one. So if the value of I is greater than x, like the value of I, so I, let's say this is I, this is x. The value of I is greater than x. So it's possibly in the old value. So you just go ahead and check it out uh, and say that 10, right? So 10 is the old value that you can find out from the map of old values because if you go to 5, 0, 1, 2, 3, 4, 5, it's 2. You can't say again 2, it's wrong, that's wrong. Instead, it's actually, oops, one moment. I is equal to 6 points to 5. 5 points to not 10 actually. Oh wait, I think I wrote it down, so I need to write it as 5, 10, 10 to 5 points to 10. The old value of 5 is 10, sorry. It's 10. It's 10 here, right? So we might end up saying it's 2, 0, 1, 2, 3, 4, 5, but it's actually not 5, it's actually 10. So I of 6 is actually 10, and then you remove this whole value, right? So you remove this old value, you check it out, and you remove this old value, you remove it, this one is removed, and then you get the other values, and this is removed, and you actually say this is 10, right? Just say 10. Now I is equal to 7. Now if you see I equal to 7, you notice that it's 8, so it's greater. So if it's greater, you probably need to look for the value and store it. Like in the, it's 6 over here, right? So if you notice one thing is this 111 has 11 1. We could have actually just changed it to 1 and 11 over here already. Because we know that if I and x and x and I are like this, right? I points to x and x points to I, then you can just interchange it. We'll see that. But anyways, um, but this can also happen in like a very different way. For example, you might come back. Anyways, I'll talk about it. So now we are at 7. 7 points to 8, right? So it's a value bigger than 7. So you might have to go and find it out because we still haven't reached 8. If it is 7 points to 6, for example, we have already reached 6 and we can look at the old values because we would have overwritten the old value to a new value. So now, but remember we are using this extra space for storing the old values, right? So now we say 7, 8, 8, 6. So we store the value of 7 as 8 before we do something. 7's old value is 8. The index 7's old value is 8. And we say 7, 7 is 6, right? So we just say this is 6, right? And then finally you come back to I equal to 8, which is 6, which is an older value. So we will find an older value. And there won't be any other 6, like anyone else will not mention 6 because one index, if it has a 6, there won't be any other index that has a 6. So you can assume you don't have to remember the value here. You can just go ahead and overwrite it. And that's something that you can do because if the value is lesser, if the index is greater than the value, you go back and look at the old value and find it out. So it's going to be 5 in our case. We look at the old values and we'll know. So 8 is going to be I equal to, so let's do that. I equal to 8. And oh, interesting. don't have the old value of 6. Why not? Oh, we actually have to put it here. We remove this and we are changing over here I equal to 0, 1, 2, 3, 4, 5, 6. We should actually store the value of 6 over here before we do something, before we change it. So we're going to write thing, but we say 6 points to 5 before we do something. So 6 points to 5. So now for I equal to 8, we know that um, I equal to 8. We know that it's pointing to 6, so 6 points to 5, right? So we actually say remove this, and then we also add, so here, why do we have to add this? Because at 6, we were pointing to, at 6, we are pointing to 5. 7, 8, 8, 6. Oh yeah, you will probably need do you need this value of 6? Does anyone else say 8? Right? If someone is looking for 8, then yeah. Just wondering if I said the algorithm right. If the value is less, go back and override it. This value can come up later. For example, 8 can come up later. Can come up, right? So you store that value. The old value of 8 is 6, right? For example, in this case, you have to store the old value of 6 so that if it comes up later, you can use it, right? It can come up before or later also. So always store the old value when you are, you know, putting, so 8, 6. Just wondering if you can actually optimize this in some way. Because 7, 6, 0, 1, 2, 3, 4, 5, 6, 7. So it pointed to 6, 7 pointed to 6, and the old value of 7 was 8, right? And now at 8, we're seeing that it's 6. Old value of 6 is 5, so you write that down and then you note it down that creates old value of 6, right? Um, just a moment. 7 old value is 6. And then it points to 5, so you just write that down. Yep. And the 8.6, you just change that to 5. This is removed, so now you have I equal to 9, right? So you have I equal to 9, and this is removed, right? And 9 points to 3, so 9 points to 3. So since it's an older value, we would have already come across an older index. So we look at the old values, it says 4, so remove it. You say 4, right? 1, 2, 3, 4, 5, 6, 7, 8. I think there has to be a 9. I think I missed something here. One moment. Oh, after 6, it's 4. 6, 5, 6, 5. So 3, 6, 8, 9, this is 3, 6, 10. So I equal to, so this will be removed now. So now we can, and we can also write down that 9's old value was, we need to write it down because what if someone else uses 9, needs 9. 9's old value was 3, right? So does that make sense? Like, did someone ask for 9? They can ask for it later, um, if needed. So you shouldn't store 9 probably. I don't know. Hmm. Let's see how this works out. 9's old value is 3, and you put 4 here, and then finally you say I is 10. It doesn't make sense though because no one else has 9 in future, as you can see in the thing over here. No one else has 9, so we have already crossed 9, right? We've already seen 9. Someone has already mentioned 9, but that is on the right hand side. So, anyways, so now we have 10. 10 points to 2, which is an older value, which means this is a previous index, so which probably has an older value because you would have, they're coming I one by one, they're coming on the index, traversing one by one. So I is equal to 10 will come up, right? And we remove this, and 10 points to 2, so 2's old value is 9, right? And you have to remove this, and 10's value is 2, right? And next we have I equal to 11, right? So we remove this. We say 11's old value is what? 11's old value is 1, and 1 points to 11's old value is 1, and 1 points to 11, which will actually remove. So now if you notice, we have 1, 2, 3, 4, 5, 6. We still have 6 of them left out here. And this can vary, right, over time. Like you don't need 8 because you've already, so you can actually see that you already have used, I mean, there's no one else asking for 11 because the one who asked was done already and they have overridden the value. And no one will ask for 10, I think, but will they? Because 10 has already been like 10 points to 2. I think 10 came up earlier itself, right? 10 points to 2. And why do we have to store this value 2? Because this has already been changed and overwritten, right? 5 points to 2, and that's all you need. So can you do this a bit differently, right? So maybe I'll just remove this from here, and map of old values is one idea, right? So in just keep this here. Say paperwork 6, and we'll write it down here, right? Now, so so here we use map of old values. We are actually iterating from I equal to 0 till I equal to length minus 1, uh, and going one by increasing I1, that is I plus plus. So we're going one by one here. Can we do this differently, right? For example, if I take this and instead of going one by one, can I actually go to the actual place itself? Like if 0 says for equal, we can just type it down, like write down that it's 0. For example, this one is going to be just 0. Both are equal, we just say it's the same. For I equal to 1, now it points to 11, right? Can I actually go to 11 and find out what is the value? No one else is going to actually point to, when I go to this value, you realize that it has the value 1, right? Or anything, let's say 2 or whatever. That index that value will not be there anywhere, right? Because it's just occurring once. And this 11 is just going to occur once in the bottom. This 11 is going to occur just once, and this 11 is just going to be, and this 1 is just going to occur once. So once this 11, we say it's 1, uh, you will need the old value, yes, of 1 because you are overriding what if someone else says 1. Like here it's 2. But you know that there won't be, let's say this is also different. We can also do a different one. Paperwork 7, 3, 4, 8. Let's say I change something. Let's say this is 1 and this is 2. This is also a good problem. So now say you go from 1 to 11, right? And then from 11 to 2. So 11, like you say that for 1, it has 2. So now you can understand that there won't be any other person trying to use 11. Only 1 points to 11. There won't be any other value 11 in the nums, right? So you know that you will need this value 2 only once, right? You won't need it again. So now what you can do is you can actually go ahead and get rid of this 2. No one is going to use it because uh, you start from here, right? So you have makes I equal to 1, right? So now if you say nums of I is equal to nums of 1 is equal to 11, right? So nums of I is equal to nums of 11 is equal to 1, sorry, 2, right? So now you can actually see that uh, like I mean, this is I basically like 11, you find out there won't be anyone else having the value 11 below. So there won't be any nums of I for any value of I having the value 11 other than just this I equal to 1, right? So now who will need this 11? I mean, someone will look for nums of 1, right? And do it. But then now what do you need? You want just this 2, 11, 2. Is there going to be any other I where I equals 11? No, nums of I equals 11. That needs the value, that means the value 2, which is basically nums of I. I mean, basically here is what you do this ANS of I, right? You say this is the thing. Basically, ANS of I equals this, and then I is 11, so nums of 11 is equal to 2, right? So is there any other I where nums of I is 11, right? No, because for I equal to 1, yes. Is there any other I? Is there any other I? The value 2, 2, which is, so you won't really need this value 2, right? Because, and this is the only 2 that's going to be here. There won't be any other 2s, right? Because no other person is going to have this 11. If they do, then no other index, right? If they do, then there'll be 2 indexes having the 11, right? So if you're forward, I think this is fine. So you just remove it. What if it is backward? For example, say 6, 5. Now, how do you deal with this? You go ahead and overwrite it. Hmm. Something to think about. that you don't need this value, so you can remove it as or from here, and you can put some other value over here. But the interesting thing is this. Um, what you can do over here is basically you can go here actually. You can store the value of old value of 1 as 11, yes. And finally, you can just go to 11 and then look for what is it saying. You don't need this. You can actually store your 11 here also. But then if someone needs 1, how will you know that you have to point to 11 and then get the 11, right? So, or whatever this is, right? So you won't know that. So you'll have to just store this. 1 points to 11. And then just a moment. Okay, so I mean, an example would be, for example, let's say um, here we have 2, 9. Okay, these are big values. Maybe I'll just look at one, right? Paperwork 9. Let's say I put some different values here. I put 10. This is forward again. Okay, that's fine. Here I can put 0 by the way. Um, can I put 0? Oh yeah, I can put 0. And I can put 9 here, and then I can put 1 here, right? So, so I can't put this here, 0, 10, 0, 9, 1, 7. You can't have 1 here, so you have 1, 2, 3. Let's say you have 4 here, and then you have 4, 5, 6, 7, 8, and you have 11 here. Right. So now what do you do? So you have this, and you have these. For one, you have 0. You go back, right? You need the value of zero's old value, right? You look at the old value, right? Um, but then what if you don't do one by one? Instead, you go like this 0, 10. You go to 11. 11 needs 2. Then 11 has 2, so you just say 2 here. And 0, 10, sorry, 10, 4. So it says nums is 4. Let's say you just take it out and just say uh, it's 4 over here. Now, do you need 0 points to 10 somewhere? And do you need 11 points to 2? Don't, I mean, sorry, 10 points to 4. Do you really need it in the future? Will anyone else point to 10? This is in the past, okay? So, will anyone else point to 10? No. So you don't need this for anywhere else. You can just get rid of this, right? So you can just be like, you can just make this as something like hyphen or null or whatever if you have a null, and you can say 0 pointed to for I equal to 0. You can actually say map of old values 0 pointed to 10, right? And now the next thing you can do is you can be at 10 actually, because you went from 0. You don't have to go at 1, the next index. Instead, you go to 10. You can do that. So you can actually store the value of this thing, right, before overwriting. So you can just say now 0 points to 10. I becomes You put 10, right? And then now I is equal to 10. So now what you see is 10 that has 4. If you remove it off, it's a problem. Okay. You need the 10 4 because you need to get what is it 4 7. If this is not there, so it's a problem. So you should not remove it. Okay. Uh, no one else needs the value 4, but someone will point to. I mean, if you remove this, we lose because we can't know then what is 10 pointing. Like 10 should have something so that we can find out what is 10. Right? Like under 10, ANS of 10. So, which is again nums of 10. So, if we just remove this 4, we don't need the 4, yes, in the sense that we won't be putting a 4 in the bottom, but we need a 4 here so that we can actually go to 4 and find out what 10 means. So, 10, and I can actually go here and say um, map of old values. You don't need the map of old values. But you do have to create for 10 the old values for. Do you need to create that? No. I don't think you need to create that because you just came to 10. You don't need to do this. Old value of 4 because you're going to go to 4 next. And there won't be anyone else pointing to 10 other than this. You don't need this 4 once you have gone to this 4. You don't need this 4. So you can just say I gets 4, right? And you can actually say this is 7 because 4 points to 7, so you can just do this, right? And now you go to 4. This is actually going backward, right? When you go forward, I think you need to keep old values or let's see. No one else will need this 4 hereafter, and you know that the value of this is this. Now, while you're doing this, how do you know when to stop? Because let's say you go back to 0 somehow, we'll come to that. Like for example, in this case, if we do this 111, then it is 11 1, for example. If it's 111 11 1, you do this, you say um, I equal to 1 and 1 moment. So you say I equal to 1, and then you say both are equal to 0, you just put 0. For 1, you just say something like 11, so you just put 1 over here, right? And you store the value of this map of old values, right? In this case, you have this, oops, this values 1 to 11, right? And then you say this is 1, right? And then you basically have this whole thing, right? You basically have this whole thing. Now you have this, right? So we basically have the whole of the value, right? Future values and whatnot. Num is changing in real time now, right? So we need to actually say this. So we are actually noticing this, right? Num value changes every time. So now after 1 points to 11, you go here, let's say. I points to 11, let's say. And we say 11. Now I equal to 11. Now what you do, you see 1, right? When you go back, uh, now do you need the value 1 anywhere else? Like, is anyone else going to point to 11? No, we have already passed through 11. So, as in, we have already seen that 1 pointed to 11 and then we got the value of that. No one else is going to say num of I, no other I is going to say num of I is 11. Right? When you go to 1, you actually find out the value is 11, map of old value. You say 11, right? Now, here you actually see 1 as the value, right? You don't change it yet. You can probably say map of old values because you're not going in any order. You're just going to places just like that. I equal to 1, I equal to 0, 11, just went to 11 directly. So now you will say something like you went here. So you'll probably say something like, I mean, map of old values. Do you say the map of old values? Do you say 1 points to 1, right? And then override this with 11. Do you do that? And do you say I points to now 1? And I points to 1, that makes sense. But then now, if you see I points to 1 is equal to 1, we see 11, we go back to 1. 11 says 1. Like we have already gone through this, right? We've already changed it. We've already overwritten once. We've already overwritten this once. We don't need to go back to this actually. Where I points to like 1, the old value is 1, and change it. You don't even really need the old value in this case because I mean that is the overwritten value. The actually old value is 11, and once it's overwritten, you're done. So how do you know if it's overwritten or not? If there's a single value, how do you make it? How do you understand if it's overwritten or not? You can actually have overwritten values uh, as a map of overwritten values. Say 1 is overwritten, and then you say 11 is overwritten, and then you say 1 is overwritten. Map or array of, so you say 1 is overwritten. This is just empty. You can say just null or whatever, so that you can quickly find out if something is overwritten or not, right? Or you can just say true or false, right? True, right? Overwritten is true. By default, you'll get false or you'll get nothing, and you figure out that there is no such key, right? So that is a bit crazy. I mean, you're still trying to use some space. You have a map of old values, and the next you have overwritten values. Can you actually do something better? So we can actually do this thing where so this was actually iterating from 0. Uh, Instead, here we are actually uh, iterating from I is equal to 0, but not going one by one, right? By increasing, right? But instead, traveling next I, which is nums of I, index, which is nums of I, right? And when do you stop? How do you know if it's overwritten already and you don't have to go there? For example, 11 1, they've already finished for 1, right? So you need to just move on to 2 now because you've already finished for 1 and you've already overwritten, right? How do you know that? Right? Um, so for that, I mean, you can't just do this. So 11, um, weird. I put 11 over here. Actually, this should be 1 only. And this should be 11. Sorry, this should be 11, and this should just be 1, right? And for 11, we say I points to I goes to 11, I equal to 11, and this becomes 1, right? I equals 1, so I think I didn't manage this here. So 0, and then we go to from 0, 0. Next, we go to next thing. This is 1, 11. How do you go just next here? How do you even know that this is done? We need, as in 0, 0, so you keep going back to 0, is it like you keep going in a loop because you found out uh, nums of I is 0, it goes to 0 again. So you go in a loop, right? So you don't want this loop. And when you don't want a loop, you just move to the next value. How do you know that you don't want a loop? How do you know it's already visited? It's already done. I think one way to do is we can just negate instead of having map of overridden values or overwritten values. We can negate if we can actually just say minus zero, but then zero. I don't know if minus zero and zero are the same thing generally. Like we can try this out, but I think zero and minus zero are the same, and in Golang, at least in language, zero and minus zero and like plus zero are all same. I think. So I would rather have instead of negating because negating is a good idea because 11 you can put as minus 11 and also you notice that the Golang code is basically taking integer, right? They're using integer in Golang code. Integer can take up signed and unsigned values, both positive and negative values. So basically you can do something like what so yeah. So here you can do something like you can just say over minus 11, minus 9 and all. But 0 alone, how will you know if you have visited or not? If you put minus 0, I think minus 0 and 0 are the same. So I don't think minus 0 is less than 0 or whatever, right? Or minus 0 is. I don't want it to be equal, but basically I want it to be negative. Is it negative? How do you check that? You can just say less than or equal to 0. And I don't think minus 0 is less than 0, and it's probably is equal to 0. So we just have to make it as minus 1, maybe negate it and then put a minus 1, right? So to know if we have overwritten a value to a new value, put new value x by doing this, where we actually say minus x minus 1, minus x minus 1, right? So we do this, uh, or minus x minus 1, or minus of x plus 1, whatever works for you. So it's all the same, right? So now here we'll say minus 1 if you have actually gone through it, right? Next time you come back, let's say 0, you store the old. Actually, if these do are equal, you just don't do anything to avoid this loop so that you already know that. But let's say you didn't do equality check for I and x. Then you can just say you can store the old value for 0 is 0, and then you say 0 points to now. You look at 0, it points to 0, so you just do that. It's crazy. Actually, I would say just go ahead and do the checking of like uh, the whole. If it's equal, then just go ahead forward, go forward, right? Uh, and if it's already overwritten, let's say 111, right? You go ahead and find out 11 has 1. You just put it here, and 1 points to 11, right? Uh, Instead of 1, you say minus 1 so that you know it's already overwritten. So it's minus 1, right? And 1 points to 11. And 11 now points to 1, and then you say, okay, so that is 11 then. And you say minus 11 in this time. Actually, not minus 1. You say minus 2 over here because 0 is minus 1. So we'll actually go in a different way. So let's do that. Um, let's start looking at how that looks like. So I is equal to 0. You just go ahead with 0, I equal 1, map of old values, so I points to 11, and then you say 11 points to 1, so it's minus 1, minus 2, so you just have minus 2 over here. This one will just say minus 1 actually, if you have already crossed it, right? So you have already done it, so yeah. So we have crossed this, we have already over, not crossed, more like overridden this. and now I points to 11, right? This is minus 2 by the way, sorry. Because 1 and minus 1, so it's minus 2. And now we say I is 11. 11 points to 1. So 1's old value is 2. Sorry, 1's old value 1 is 11. So instead of doing this craziness, we'll actually be one moment. Let me actually get this. And I can probably write this down somewhere else. Here, we just take our 10 and you don't do this craziness. So you don't have this where you actually go ahead and oh, this is going to be 0 and this is going to be 0. This is going to be 1, right? And you go to 11. The old value of 1 is 11 and you say 1. You say I equal to 11. I equal to 11 map of old values. Um, you have I equal to 11. 1 equal to 11. Um, and you say 1 then goes to 11, right? 1 goes back to 11. So you remove that, right? You say 11 then, and then I goes back to 1, right? And then you say 1 now points to 1 again. It's equal. Next 2 point, I mean, it's equal, you just don't do anything like it. Actually, this is already overridden. You don't even have to do one again. Then that would be twice ans of I. So you shouldn't actually go here and move ahead, right? So you should actually go to 2 and not do this. This is wrong, right? This is wrong because you are going back to 1 and you're trying to now work with that. Wrong or problematic, right? So instead of going back to 1, or you can go, but you shouldn't actually just do one more ANS of it because uh, we don't want to do we don't want to do uh, nums of basically we don't want to do ANS of ANS of I. We only want to do nums of ANS of I, which is equal to nums of I, right? So it's like one level of processing. If you do this, you'll go again into like double level of processing. Like one. Now you actually go ahead and look at. You can look at the old, but old value is gone. There's no old value. This is a new value, and you don't know if this is a new value or there are no old values for 1 clearly. It was 11 and you have used it. You go back to 1 though because you're going around trying to understand just by looking at what is the value and go to the index that has this value. Go back to 1, but then you have, uh, do you have any 1 points to 1? Do you really need to do this? No, you should visit only once, right? So by doing this, we also ensure we visit every index only once and override it only once, right? You don't want to visit it multiple times unnecessarily, right? We don't want, so basically, we don't want to do this. We don't want to visit an index multiple times or override a value at an index multiple times, even if the value is correct or right, as this is a waste of time, right? So we don't want to again and again go to the same place, right? It's a waste of time. So what we'll do is we'll actually say we'll go to I 0, okay, and we make it -1 because uh, we to say that it's visited, and yeah. Finally, what we do is we actually why do this -1 so that we can actually add one later. If we just put minus, we can actually make it plus later at the end after everything is done. After everything is visited, we can just make it as plus. But since zero, we can't understand zero from -0. We can't differentiate zero from -0. We have to actually do a -1. So yeah, so -0 won't make sense. So -1. Finally, what we do is we do the reverse of this, which is actually you know make it as the reverse of this would be adding one and then negating, or we can just negate, right? And we would actually get more like whatever is the value, right? Here we're saying y is equal to minus of x plus 1. So to get x, we actually say it's uh, minus y plus 1, right? So to get it the other way, so basically you get the value x by reversing it. So y is equal to f of x is equal to this, right? And to get x, we basically do this. Either minus of f of x, which is basically minus y, so minus 1, basically this. Or you can say it as minus of f of x plus 1, right? So if you do minus of this, you will get x. So, okay, minus x minus 1, and then you go ahead and put this back as 1, minus of, okay, sorry, this is actually like this. I think it's right. So minus x, so minus y, and minus 1. Wait, wait. Minus y minus 1 is the right value. Minus y minus 1. Right? So if it's 0 becomes minus 1, how do you make it back to 0? Or let's say 11 becomes minus 12, right? How do you make it back to 11? So you just, uh, first of all, reverse the negation, we can make it 12 and then minus 1. So we understand that, for example, 11 becomes minus 12, then minus 12 becomes 11 when reversing, right? How? Because 11 goes through this whole thing of like minus 11 minus 1, which is basically minus 12, and minus 12 becomes 11. How? Uh, Reversing is this. Uh, So you need 11 out of this. So basically, either you can do minus 12. So minus of, you can do either minus of this and then say minus 1, or you can just say um, minus of minus 12 plus 1. It's basically y plus 1 and then minus of it. So as you can see here, this is also equal to minus of y plus 1. So you can just add, this is y basically, this is y, right? This is x here, minus x minus 1 is y, right? This is y, and we're trying to give here minus of y minus 1, or minus of y plus 1, right? Y is 12 minus 12, right? So you can also see this as this minus of y plus 1, right? Which is also equal to minus of f of x plus 1, right? So yeah. Now basically what we're trying to say is now this 0 will be now minus 1, because 0 minus 0 minus 1 is minus 1. So that now we know that. Now before doing this, you need to know what is I. So you just make it as before you do this, you need to actually say I is 11, right? So you say I is 11 before doing this, and then because both values are equal, now we just remove it, change it up. No, not both values are equal. 0 points to 0, okay. Minus 1. 1 points to 11, okay. Wait. This is minus 1. Once you know that actually it's the same value, what you can do is now I hasn't changed. But what you can do is if I is positive, then if I is negative, for example, okay, not I, the value of I is positive, then you can use it. If the value of I, the value at index I is negative, then move on to the next one, right? If nums of I is negative, do I plus plus, right? So while this loop, right? So do I plus plus till it's not negative, right? Now next we say 1, it has become 1. So for 1, we say the number of whole values of 1 points to 11. Now 11 has 1, so you are going to overwrite it. When you overwrite, you're going to, instead of saying 1, you're actually going to say minus 1, which is minus 2. So you say that, and then you have the old value here, 1, 11, right? So next, you actually say I points to 11, right? So when you get the value itself, you just understand that the old value of I is 11. The old value at index I or 1 is 11. And then now I becomes 11, right? Instead of 1, right? Now, then you change the value, right? First you change the value and then you say, actually you can't change the value. Just a moment. Actually, I will probably do another part of this. Or actually, I will do it one moment. Let me just pause this. Hello, folks. So I'm back, and let's get back to what we were doing, right? So the idea is we'll be iterating from I equal to zero, but not going one by one, like by increasing I plus plus, but instead traveling to the next index, which is nums of I. So if it's equal to zero, yeah. If I and the value of nums of I are the same, then we'll not do anything. So if I and the nums of I are equal, we don't do anything, right? So now we go ahead with that. Finally, what you see, well, if you do something, right, what will happen is, uh, oh, we do actually, uh, we don't do anything, what do you say, any traveling, yeah, right? But if you think about it, there's not much to do really. You say this. So I, nums of I is 0, and again nums of I is 0, 0, so you'll get 0 here. Um, and instead of storing the old value of 0 as 0, and then putting 0 here, and then going to 0 back again, and you won't put 0 here, minus 1, and then going back again to 0, the next value, next index, this index is 0 again. And then finally be like this is minus 1 because I've negated it, then you go here. Instead, I would rather just be like, I don't want to do this traveling, unnecessary traveling, like unnecessary storing of 0, old values, 0, and whatnot. I would rather be like, if it's equal, just move on, right? Now, this idea of whole, I mean, we say that we don't go I plus plus like next. But I'm assuming that once you start going into this whole idea of like 1 goes to 11, 11 goes to 1, and you go back to 1, you notice that you've already visited 1. So next you go to 2, 9, 9, 3, 3, 4, right? 4, 7, 7, 8, 8, 6, 6, 5, 5, 10, 10, 2, 2, you go back, right? So we started from 2 actually, if you notice. So let's see how that goes, right? This whole thing of if you're at 2, if you keep traveling, right? So 1 and then 11 to 1, right? Um, so 1 to 11, so 1 to 11, and then go from 11 to 1 again, values of I, right? So then you're like, okay, now you go from 1 to 2, you go from 2 to 9, right? Then you go from 9 to 3, right? And then you go from 3 to 4, you go from 4 to 7, and you go from 7 to 8, and then you go from 8 to 6. If you notice, we actually visit everything only once. 2, 9, 3, 4, 7, 8, right? Like this whole 1 to 2, we just move just like that. This is just I plus plus. Since 1 is already you know traveled to or overwritten. So when you go to 2 to 9, you take the value of 9. No one else is going to actually say 9. Right? So you just take this 3, put it here, and you go here. You do need the value of 3 though, as in you shouldn't remove this because from 9 you have to go to 3 next to find out what is nine's value, right? So you can't just remove this. You need this value to put it here, and you also need this value to go to 3 next, right? So you put 3 here, and then you go to 3. You notice 3 is 4, You put 4 here, and you go 4, 7, you put 7 here. You don't keep the old values really after this anymore. Right? When you keep traveling, you don't keep the old value. Um, so 3, 4, 7, like this is overridden, and then you basically go to 4. You have I, right? That's all. That I is just kept here. So in this case, for example, you just say 1. You don't change this though, but and then you go to I equal to 11. Go here, you go back, you're like, okay, it's already 11, so is it? You need the old value of 1 though. Okay. We'll see about it, but 8 points, okay, 7 points to 8, 8 points to 6, 6 points to 5. They've never reached 5 before, so it's all good. And then 5 points to 10. From 10, we go to 10 to 2. Now, this is the second time we are actually reaching 2, right? So here we actually will do 3, and we notice that 3 is also already traveled, right? So you go on, like you go on to the next one, 4, you've traveled to 4, 5, you've traveled to 5, right? So you basically do 2 to 3 because you've already traveled to all of these, right? And 3 to 4, and then 4 to 5, and then 5 to 6, and then 6 to 7, right? 7 to 8, and then 8 to 9, and then 9 to 10, and then 10 to 11. Now, once we notice this, once we hit 11 like this with I plus plus, right? Not because of traveling, but because of I plus plus, right? Now, this is also overwritten, right? Let's say. So you do I plus plus 11 to 12, but then this is not there. This is larger than the, this is equal to the length of the thing, right? This is since 2 is already visited, 3 is already visited, 4 is already visited, 5, 6, 7, 8, 9, 10, 11, right? Now, when I becomes length, then we stop, right? So instead of saying once it becomes length minus 1, because that will be tricky because even here if you see I is 11 over here, right? So you notice that all these values are negative. The only problem I'm noticing here is what if uh, the previous values of I were also like, let's say you came to 2, you've already visited 2, why should you go to 3? Why can't you just go back to 1 or whatever, right? So what's one thing we can do is we can actually start from 0 and find out the um, first negative, like positive value, and start from there maybe. Because instead of doing I plus plus, right? So we can actually go to 0 and we can say start from 0, search for first positive value, right? From I equal to 0. Whenever this happens, right? And whenever we go back to the same place, um, so we say 1 to 0. Since this, right? And then we go from 0 to 1 since it's already visible, right? So I is 0 since 0 is already visible, right? So then 1 to 2, right? And then from 2 we go to uh, yeah, we go to 9, right? So we have already traveled. 1 is already traveled, yeah. 2, from 2 we go to 9, we travel, right? So here again, we can actually do this. We can say from 2 it goes to 0, and 2 it goes to 0, and then from 0 it again comes to this, right? 2 goes to 0, since 0 is already visited, 1 is already visited, and you have 2 is already visited, travel to, right? Since 1 is already traveled to, then there's a I'm just wondering how you do this because you have already counted this once before. Here you say you start from 0 because you've already traveled to this. Here you say plus plus. Hmm. Okay, start. Yeah. Look for the positive search. You need to know when you're in a search phase. And if you're not searching, you need to be done. Like once you search for the first positive value, I think search ends here. Search ends here, right? You travel, you go find out, and then once you notice that um, search ends here, so whenever you're searching, you need to start. So since one is already traveled to or over to, um, so this is this. We say first for positive value from 0. Okay. Uh, so since this is basically its value not traveled to. Search, then we stop search and say that ANS is found, computed, and just remove the signs, negative symbols, and add 1 to get form of get ANS of ANS. Right. Search ends here as I is greater than or equal to length. Right. So when it becomes this, we say we're done. See the form of gain is computed, just remove signs like it's -1, make it as 1, and then subtract 1. Right. For example, if it's -1, it basically means it's 0. If it's -2, it's 1. Right. So we have remove the negative symbol, for example, here. Um, remove this negative symbol, right? Um, so here, remove the negative symbol, subtract 1. That's all. So it's minus y minus 1, right? Remove the negative symbol, right? Minus y, and then minus 1. Like do the C of it. So, I'm thinking the old values, so instead of map of overridden values, we have to do this, right? So we do have map of old values, yes. No map or array of overridden values. So I'll remove that. That was here though. So here, how we find out is basically what we do here is I is 11, 1. So let's start from here and we say that I is 0, I is 0. We actually find out that both are equal, so this if number of I is negative, right? So um, so after this, since it's equal, we can start from first again search. I don't know. That's something we can do because if it's equal, and we'll just say this minus one is visited. Um, the next thing to do is here it's zero. Okay, and every time do we actually go and find for a interesting. This is a question mark. Why I plus plus? Why not just start from the first? Or do a search from I equal to 0, right? So, and do the same, right? Do the same and find first positive value, right? Nums of I. So, you will notice that nums of 1 is 11, so it's positive. So, now you're going to actually find out, like, you're going to travel to 11 and then say, nums of 1 is going to be 1 because no. Answer of ANS of 1 is going to be 1 because at least like you need to get 1 and you're going to do a computation to say that it's actually visited, so you'll say minus 2. But you'll store 11 before that, right? And once you go to 11, you actually go to 1. You say it's 1. So now you find out. So now you find out 1. No? So map of world value is this, and finally you say I is 11, and then you go to 11th thing, right? And okay, sorry, here we go to the 11th index, and let's put the index everywhere so that we know what's going on. 11th index is here, and we're like, okay, so we say we want the value, like we want this one, so you get you realize that this is a overwritten value, so you go for the old values. Or you can check the old values first. Old values says this, so we remove it and actually put 11 in your thing, right? Um, so let me just put that in. Right, so we'll actually say remove this and say it's 11, so it's minus 12 by the way. So you do that, and once you do this, you also store uh, value of 11 as 1. Do you need this, the value of 11 as 1? Like, do you need the old value? Will anyone else ask for 11? No, right? How do you know that no one asked for it? That's the question. For example, we were traveling from 1 to this. We kept the value of 1, right? Because we thought we'll need it later. Uh, because okay, so if you remove it from the old value, maybe you don't need it. Basically, you're getting the old value. If you get an old value, it means that you don't need to keep um, the old value of uh, 11 because if it's getting like if a value is being put on by the old value, it means it's already what do you say? For example, if there is a if there is a k where index is just I and then k, right? And continuous nums, right? So this is gonna be x. We'll call this y z. Okay. So x is already, let's say I is already visited, right? K goes to I. If it's already visited, then we need K is valid. In this case, 1 and 11, okay. So it's 1, 11, 11, 1. That's the problem. What if it was not 1, 11, 11, 1? 1, 11, 11, 1. What if it was 1, 11, 11, 2? Right. Go to 11, go to 2. We need the value 2 though. Will anyone else say 2? No, because you just traveled to 11. When you travel to 11, instead of doing a search, I think it's not a problem. If you're doing a search, then yes, we do a search here. It was equal search. Yes, when you do a search, you need it. When you do a travel, you don't need it. Okay. You travel from 11. came here, and no one will require the value 2 because there's only one element here. So you will require it only after changing this word. Uh, you'll be like, this is 4, and you'll be like, go travel to 2, and put the value here, say I equal to 2, and put the value here from this 9, and you travel, put the 9 here, you don't need 2 anymore. So from 9, you go here, say 3, you don't really need 2's value there because it was traveled there. When you go to when you travel and get the value, you don't need that. Yeah. 9, 3, 4, 7, 8, you don't need this value. 6, you don't need this value. You already got this if you want it. You say you go here, 5, 5, 10, 1, and you go back to 1, you travel to 1, realize 10, you need 11. Right? So you do a search here actually initially. So when you're actually in equals, you do a search, right? So you do a search, that time you store a value. Hmm. 1, and then you get the value 11. You travel, the destination place, the source place of a travel, once it's overwritten, before overwriting, you store the value because after search, just after search, it will be there. The key stuff now. Hmm. This is crazy, too many old values. Still trying to understand how we can do this in a better way. Hmm. This is increasing one by one, but too many values here. This is also too many values. Right. Uh, right, check if this is the correct answer. Being in paper value and 6 is the answer. What is the question? What of old values? This is same. Yeah. Anyways, what's different is now let's talk about value. Hmm. I mean 6. Do they have the same question? Yeah. I think the whole thing is same. No, it's not. Yeah, it is. So whole of this is the same. So the only different thing over here is the stop like top start. So think let's remove this. Anyways, it's fine. This is actually a good PTW. Yeah, things from there it's a PTW. Not sure these two are the same. One 0 1 2 5, 0 2 1 5 4, 0 1 2 4 5 4. Oh, yeah. this is there in between as well. So, anyways, hmm, too many ideas at once. I think there was some idea going on here. There's a cave. Basically, I went back to one. Remove the old value. I went back to one, and then thing is, it's more negative. So you start a search, and you end up here. Right. Hmm. Can be in the past, can be previous, or after you can count the details. So from 11 you go to 1 backwards. You can also go forwards, right? What if it goes forward? For example, there are more numbers. Like for example, it says 12, 13, 14, 15, 16, 17, and say 17, it goes forward, right? So it goes to that number, and that we just keep continuing. We do a travel, and we put the value here. We don't store the value because we did a travel, so specification is a travel. But if we do a search from the start, we have to actually search from the start. Let's say it goes to 17, and 17 is, let's say 17, and then you go to say 15, and let's say 15 is somehow already traveled to, right, somehow. And you can't just start from, let's see. Uh, so let's see if we can actually get a bigger question. Paperwork 11. I want a bigger question, so this one say 13, 13, 14, 15, 16, 17. I want to go to some value before and start. So I want to go to some 17 itself here. So from 1 to 11, 11 to 17, 17 to 1, or this 12, 16, one memory is 11. So if it goes 1, 11, 11, 17, 17, 11, we go back to 11 and we notice that it's already visible. If we do I plus plus, it's a problem. So we have to start from first only, right? So if you travel 1 to 11, 11, 11, so if you start a search here actually, and you end up here, first positive number. This one you need to keep track of the value of 1 because you'll need it later. Where is it even being used? Oh, this can't be done actually. This has to be done. This can't be done. Okay, so suddenly, because there's already one line. One line learns 17, 1 goes back here. What if it goes back this? 11, 17, 17. Hmm. These are all going to be the same. Hmm. This is 17, 1. Except it is this, it's already traveled. Can't put as 11. Not if it is 10. It's not already traveled. I want to already travel something. So 1, 11, 11, 17. 17, let's have about 16. And this is 17. 16, go to 17. 17, I go, I find out it's 17, and then I go to 16, and it's 17. I go here. I can't just start from I plus plus. That doesn't make sense because that will just lead us to, I mean, if we just find out that 16 is already visited, like this is already visited. Go here, in 17 you visited, and then you realize it's all done. That would go wrong. You just do I plus plus without doing a search. You notice that it's negative. You just go to the next. It'll go wrong here. This is true even with places like I think if you do something like paperwork, 12, you do something like 17 goes to 111, 11, 17, 17 goes to this. 17 goes to, let's say, oh, there are two 17s here. That's not. There can't be two 17s. There's no one over here. It has to be a one. It can't be a 17. Hmm. This is wrong. Okay. It has to be a one. It can't be a 7. Can't be 11. It has to be a one. It has to go back here. So are we saying that wherever we start, we'll go back? 2, 9, 9, 3, 3, 4, 4, 7, 7, 8, 8, 6, 6, 5, 5, 10, 10, 2, 4 plus. It goes back to, can we just do a plus plus thing? Will it always return back? Either going to be traveling or it returns back. We start to find out search anything. So, hmm, interesting stuff. There's, when do we find that? Um, hmm, I've got the question is wrong. 11, there should only be two values. 0, 11, 9, 4, 7, 10, 5, 8, 6, 3, 2, 17, 12, 13, 14, 15, and if you go to something, you'll come back. Okay. So you can just do plus plus maybe then. You don't have to search for something. When you do plus plus alone, you have to keep track of the value. So you go back to 2. You might have to keep track of 11, for example, over here because 1 will be used up when you get it. And go to 11, and 11 will use 17. We'll just say 17 here, and go, you will travel to 11. You travel, the destination doesn't need to use because this 17 is already used up. You just travel and you would have used it up to 17. And if you don't travel, because in such cases where you don't travel, you just do plus plus because if these were equal, you just say 0 and 0, value is the same. You don't have any traveling to do, just move to the next one. You travel around, you will come back to the same point. Is it possible to start from here, travel around, and come back to a place here, and then come back to this place? Where it's negative. It's called, is it possible to start? We've already started with 0, 0. Can we start with something else? Maybe paperwork 12 can help with that. We don't have to start from 0. We can just say 0, right? We can just leave it as, I don't know, 6. 6 is already there. We can make this 6 as 0. Now let's start, right? So we have a 0, we have 6. So 0, 6, 6, 5, 5, 10, 10, 2, 2, 9, 9, 3, 3, 4, 4, 7, 7, 8, 8, 0. We come back to 0. Hmm. Is it ever possible for something to start off and come back to a negative value? I think it's negative. We need to find that out. I'm only thinking this out loud, but I'm not doing this. Let's say we do actually find out that 0, 6, right? 6, 5. So we start from here, so we need um, the initial value, the old value of 0 is 6. Right? Because there is going to be someone who uses 0. The 0, 6, and 6, 0, then we could have just been right. Yeah, I mean, you could have just put old value of 0 as 6 and old value is as it is value, and then put 0 over here, minus 1 over there. Right. Hmm. I actually put this as 0. This is 5. Let's see how that goes. 0, 6, 6, 0, right? How does this work? So 0, you go to 6, 0, so you remember that you put -1, but before that you remember that 0's old value is 6. And then you go to the old value next, right? The changed value. So you go to that value, you store that old value because you probably need it later, go 0 and then next. It goes back to the same value, and you realize old value, put it here, and then you do plus plus. Once you always start and come back to the place. Hmm. Start from the left, you'll always come back to the place. Okay. What if you start from the right? 17, 16, 1, 111, 17 will come back. Okay. You need the old value of 17, but once you actually come back to 17, you will get rid of the old value of 17. You need to put the old value only in the do plus plus and start off. Yeah, like, don't have to actually do a. I think you'll always come here back to the same place, whatever it is. How can we do this theoretically that you'll always end up somewhere back? 3, 4, 7, it goes back. Can I do something like 2 here? We have 7 here. So 9 goes forward, 3 comes back. Hmm. Even if it goes back, it's kind of like that. So it's like a mixture of 9%, 3, 7, 5. This is between that. Hmm. If you start from 5, 5, 10, 10, 2, 2, 9, 9, 3, 2, 4, 4, 7, 8, 0, 0, 6, 6, 12, 5, 4. We go back to wherever we start from. Hmm. Since we start from the left, we go back somehow at some point. Once we go back to the same place, we can actually just start off. When we start the next, just like this plus plus, we need to remember the thing, or else we don't. Let's write a code this time. Let's see how it goes. Um, we have go.mod. We'll say um, array.go. Ark is array, as you said. This one actually we can actually keep it as. Let's see. I think the question was around. Let's do this. The array. So now we have this. Let's go test. I have test cases that I actually have done once before, so let's do those in test cases. Yeah, these, for example, input, output, so, So we can use that. Say package array, and there's input nums, right? And the output is also the same thing. Hence, actually, the interesting thing is nums, okay? And say this. The thing is, we need to find out what is the build array permutation, right? So you just copy the signature of this. It's in Golang, right? So that's what we want. Okay. So let's close that down. We have build array, right? And test build array.